Algebra 3, Chapter 2, Section 1, Linear Equations in Two Variables. Okay, first let's review what slope is. The slope of a line indicates how steep the line is and in which direction it is slanting. A positive slope means that the line is going up or increasing as it moves from the left to the right. Remember, when we analyze a graph and we look at increasing and decreasing, we always want to read it from the left to the right. A negative slope means that the line is going down or decreasing as we move from the left to the right. A horizontal line has a slope of 0, and a vertical line has a slope that is undefined. Now, the slope itself is the change in y over the change in x. Another way to write that is delta y over delta x. The triangle is the Greek letter delta, and it represents change in math and science. The formula for slope is y2 minus y1 over x2 minus x1. This is a formula that you should know. You've used it before and you should have learned it at some point, and you need to know it again. So if you've forgotten it, now is a good time to get it back into your head. Now you can graph a line if you know just one point and the slope. What you do is you put the point on the graph, and then you use the slope to move up and over to get to another point that will be in line with it. For example, we're going to sketch the line through the point 2, 3 with a slope of 3. So what we did is we put the point 2, 3 on the graph, and then we moved up 3 and over 1. Our rise was 3 and our run was 1. Placed a second point, and then connected the line through both points. You can estimate a slope from a line by picking a point on the line and then moving up or down and right until you arrive at another point on the line. For example, we're going to estimate the slope of this line. The first thing we want to do is pick a point, say 0, 0, and then we're going to count up 3 from there, and then to the right 2 till we reach the point 2, 3. So our slope is 3 over 2. Now let's try this example. Find the slope and y-intercept, if possible, of the equation of this line, and then sketch the line. Pause the recording to try this and resume the recording to check your answer. Okay, you should have gotten that the slope is -1/2 and the y-intercept is 0, 4. You could have gotten this by graphing it and examining it, or from the equation itself. You may recognize the form of this equation. It's called slope-intercept form. It's y equals mx plus b. The -1/2 would be the m, which is the slope, and the b is the 4, which is the y-intercept. Now let's find the slope and y-intercept, if possible, of the equation of this line and sketch the line. I suggest that you solve the equation for y first. That will help greatly. Pause the recording, try this problem, then resume the recording to check your answer. So the first thing we did is, as I suggested, we got y by itself. We subtracted 7x from both sides and then divided everything by -6. That gave us the equation y equals 7 over 6x minus 5. Our equation is now in slope-intercept form, y equals mx plus b. So the slope is easy to read off of the equation. It is 7/6, and the y-intercept is 0, -5. Also very easy to read off the equation. Plot the point 0, -5, and then you can count up 7 and across 6 to get to the next point and connect them. Now we're going to find the slope of the line through each pair of points. We're going to use the formula for slope. Again, remember, that's y2 minus y1 over x2 minus x1. Pause the recording and give this a try, and then resume the recording to see how you did. Okay, our first pair of points, we're going to have 9 minus 0 over 0 minus 6. That gives us 9 over negative 6, or negative 3 halves. You'll notice that it doesn't really matter which y I choose to go first for the numerator. However, whichever y I choose first, its matching x value must be first in the denominator. So if I had decided to use the point 60 first, it would have been 0 minus 9 over 6 minus 0 and would have given me the same answer. Our second set of points, we have negative 2 minus 6 over negative 3 minus 1, which is negative 8 over negative 4, which reduces to 2. And then our final set, we have negative 1 minus 4 over negative 6 minus negative 6, which gives us negative 5 over 0, which is undefined, meaning that this line is a vertical line. Now we've already worked with linear equations a little bit here, but just to remind you, there are 3 forms of linear equations. The first is called point-slope form, and this is very useful when you have a point and a slope. It's the one you can use first, and we usually don't leave equations in this form. We usually want to change them either to slope-intercept or standard form from here. Slope-intercept form is the one that you're probably the most familiar with, y equals mx plus b. And then general or standard form is ax plus by plus c equals 0, although sometimes it is written ax plus by equals c. The a, b, and c here are real numbers, and then x and y are what they usually stand for. This form can be helpful when you are graphing by hand, and it is also useful when you're solving different equations, a system of equations, many equations at once. A horizontal line has the form of y equals a number. For example, y equals 3 would be the horizontal line that goes through 3 on the y-axis. A vertical line has the form x equals a number. For example, x equals negative 5 would be the vertical line that goes through negative 5 on the x-axis. Parallel lines will have the same slope, a little fact you learned in geometry and reviewed in Algebra 2. And we also learned this in geometry and then reviewed it in Algebra 2. The slopes of perpendicular lines are negative reciprocals. What that means is if the slope of one of your perpendicular lines is 1/2, then the slope of the other line would be negative 2. So now we're going to find the equation of the line that passes through the given point and has the indicated slope. So you're going to be using your linear equations. For these, you need to start with point-slope form, and then you can change it to slope-intercept from there. The reason we like to change it to slope-intercept is it makes it easy for graphing, especially with technology, and easy to read the slope and the intercept off of. Pause the recording and give them a try. Resume the recording to check your answer. Yeah, first equation, as you could tell, we did y minus 6 equals negative 2, x minus negative 3. We then distributed the negative 2, and y minus 6 equals negative 2x minus 6, and then added the 6 to both sides, and we get y equals negative 2x. For our second equation, we have y minus negative 3 equals negative 1/2 x minus 2, which gives us y plus 3 equals negative 1/2 x plus 1, distributing the 1/2 there. And then finally we have y equals negative 1/2 x minus 2. And our final equation is y equals 5/2. Our slope is 0. You can put this in a point slope if you want to. You would get y minus 5/2 equals 0 times x minus 4, which would give you y minus 5/2 equals 0. So again, just y equals 5/2. Now in this example, you're going to find the equation of the line that passes through the given points. So I'm giving you 2 points. You need to find the slope, then put the slope and either point, doesn't matter which, into point-slope form, and then finally solve for y to put it into slope-intercept form. Pause the recording as you do these and resume the recording to check your answer. For this problem, you should have gotten a slope of -3/5. And then finally, when you get it solved for y equals -3/5 x plus 2. Now try this one. And here's the answer for that set of points. Y equals -1/2 x plus 3/2. And then finally, try this point, this set of points. You'll notice when you do the slope on this, y2 minus y1 gives you 0, which means that we have a horizontal line here. And the equation of that line is just very simply y equals -1. You're going to write the equations of the lines through the given point that are parallel and perpendicular to the given line. So I'm giving you a point and I'm giving you a line, and you need to find the equations of the lines that are both parallel and perpendicular. Remember the relationships of the slopes of these types of lines. So what you need to do is you need to find the slope of the line that I've given you first. The parallel line will have the same slope, and the perpendicular line will have a slope that's a negative reciprocal. Pause the recording, give this a try, and resume the recording to check your answer. Okay, here we have solved for y, got it in point slope form, and we found that our slope is -3/4. Then what we're going to do is take that slope and use the point that's given to us and write a linear equation. And when we do, we get y equals -3/4 x plus 3/8. That is the line that is parallel to the given line. And then finally, we're going to find the perpendicular line. Our slope this time, instead of -3/4, we'll be using +4/3. And there you can see the final answer for the line that is perpendicular. Let's try one more example of this. Write the equations of the line through the given point that are both parallel and perpendicular to the given line. Same as before, same procedure. Pause the recording, see if you can do this, and then resume the recording to check your answer. When we solve for the slope, we find that it is 1. Nice number to work with. So the line that's parallel will have a slope of 1. When we put the point and the slope in and solve for y, we get y equals x plus 4.3. That is the line that is parallel to the given line. And then we're going to find the perpendicular line. Instead of a slope of 1, we're going to use a slope of -1. And you can see there we put in the point and -1 for the slope, and we get y equals -x plus 9.3.